it sounds like a lot of you are interested in school, specifically science, microbiology. I heard a little bit of IT, you know, more on the computers and technology side of things. Some of you are undecided. We had a material science person. Who else do we have? What else? What kind of questions do you want to ask Rachel about what she have to do to get into grad school?
Can I ask a question?
Yes.
Let's just start from like the beginning, like your experience with like applying and stuff, because that's where I'm sure most of us are at right now. Like, I don't know where to start looking. I don't know about what's a GRE score. I don't know about any of that.
Yeah, I can speak to my experience, and please know that this is for a PhD program in a biological science. So that definitely shapes the experience. If you're going for a master's, it'll be slightly different. I started my search for what school I wanted to go to based on where I wanted to live, honestly. And then I looked for schools that were ranked highly there just by looking up just like catalogs of what schools did microbiology, which is the specialty I wanted. I was kind of lucky to go in knowing that, but I was pretty open. But like you, I didn't really know where to start. So I picked something and started there. So I looked at schools that offered a PhD in microbiology that had were in places that I liked, and then their ranking. The ranking doesn't necessarily matter. It was just a way for me to find a school. I also considered cost pretty strongly, which is why I ended up going for my PhD. In part, I knew I maybe wanted to be a college professor someday, which would require a PhD, and that didn't scare me. So you guys are all here too. You're just as crazy as I am. But yeah, so I looked for places that offered the degree I wanted. That's the most important thing. But yeah, so my specialty was micro, and then I looked at what professors were there. Because for a PhD, a lot of your time is spent researching a specific topic under a certain professor. For a master's, sometimes there's a research component, but not always. Sometimes it's just a coursework requirement. If you're doing your thesis or a research thesis for your master's, you'll still need a professor to work with for that. So I looked at the professors and what they were studying. That's usually out of date on their website, but you can look at their most recent publications, and even looking at the titles, you'll start to get an idea of what they are interested in. So I tried to find people who were interested in similar things to what I was interested in, which was really broad at the time. I really love everything, which is the problem. But I wanted to combine those. So I found places where there were some professors who were able to combine those. And I'm working for one of them now. She hadn't started when I was looking, but it really worked out nicely. So what I'm trying to say with that is the best laid plans doesn't really necessarily mean anything. As long as a few of the boxes are checked, I think you'll find people you want to work for.
Nathan,
any other questions on admissions?
I think Nathan had a question, right?
I was going to say nearly the same thing as Lake. Like, where should we start going from now? So like you said, start at location and then move into professors, like undergraduate research. That was good. Thank you.
Other questions? Well, I have a question. Oh, Corey, go ahead.
So did you have any undergrad research prior to applying to graduate schools, and how much of an impact do you think that had on your application?
Yeah, for the specific specialty that I'm going for micro, for those hard sciences, probably computer science as well, I would say some research background is very important for a PhD for a highly ranked program. Different schools expect different levels of background. So I was the only straight out of undergrad person admitted in my cohort, because I was able to get undergrad research that was actually hands-on research, which is a credit to the UW system. I think that a lot of places don't offer that. A lot of my peers, they got research positions, but it was just washing dishes, which isn't a lot of good experience for critical thinking. So a lot of them had research positions afterwards. that helped them, or their applications become more competitive. I did some research in chemistry and in microbiology, and I actually was able to publish before I submitted my application, which I think made an incredible difference. So if that's a possibility for you, I would look into that. If it's not, that's okay. I think research experience is the most important part for a PhD track. If it's coursework track, it's not as critical. But for a research track, I would also suggest getting that out of the way, because research at the bench isn't for everyone. Your experiments are gonna fail like 90% of the time. If the experiment was gonna work, like a 50-50 chance, somebody would have already done it. So you have to be ready to, keep trying over and over and troubleshoot your experiments and critically think for that bench work. And it's hard, but it's really fun. I get to throw stuff at the wall and see what sticks basically every day. And you don't really get to do that in many jobs.
I guess on that note, how did you initially come upon your research opportunities? Like, how did you find those positions?
Yeah, I just walked up to people's offices and knocked on their door and really nervously, like shakily asked if they had any research positions open. And usually they were like, we'll see. And I just kept up with that. I was pretty diligent about it. Meeting your professors is really scary for no reason. They're just people. But once you get past that, it's really not, in my experience, not difficult to find research opportunities. I actually found a couple outside of the ones that I was working on there, just because I asked people what they were working on, because I was interested. People love to talk about what they love to do, and most of your professors love their research. You can ask them about it. They'll want you to do it.
Cool, thank you.
Yeah.
So I have a question. I don't know. Are we allowed to just do like random questions that don't really have to do with anything?
Go for it. Let's see.
Okay.
What comes out.
This is kind of about like research, but I'm kind of looking forward to next summer, and I'm looking at, would it be better to have an internship, or would it be more worthwhile to do undergraduate research like over the summer? I don't know which one would be better for grad school.
Are you, I guess either way would probably be fine if you get hands-on experience. I'm not sure how you want to twist your specialty with German as well, or what your job prospects are. An internship might give you more of a leg up. I think it's really dependent on what you want to do. Think about how it positions you to be unique or come to the table with something that somebody else doesn't come to the table with. Because when it comes down to it, we all have very similar undergrad experiences. That undergrad research may or may not be fruitful. That's just the nature of the beast. But getting those experiences and trying to think about, what your intersection is. I think that's helpful. But you don't need it yet either. You can always get that figured out in grad school.
Okay, thank you.
That was a very good question, that one. Not random at all.
I have another question.
Mm-hmm.
If you maybe go through just like, what's the daily life of a PhD student, or like even more specifically at Colorado, what's it like living at that university or going to that university?
Yeah, so I'll answer for non-pandemic times, because that's most of my time here, luckily.
Yeah.
So
it's not a pandemic when we go to.
yeah. So most of my day-to-day for grad school in Colorado, at the specific school I chose, which is pretty laid back, I will say that. That was something I was looking for. When I interviewed, it was a place that was pretty reasonable about human time, like making sure you have time to go home and like eat and shower. So I prioritize that in choosing a program. So my days usually start around 9 because my boss prefers we're all in at business hours. Some people don't start till noon. Some people start at 7 a.m. because enough people don't start till noon that they're able to get quiet time. My first year, I spent 2 hours each morning in class. And so did all of the STEM graduate students, including computer science, who are at the same university as I am. And that was a core course just to get everybody up to the same place and it was a lot of background about biology. And then it would be research from there. So I would go to the lab I was working in. My first year, I did 3 rotations in different labs. So I spent about 10, 11 weeks in each of 3 labs and got to try them out. That's pretty common in STEM graduate schools now for PhD, but not all. Some of them have direct admission into a lab. So you have to actually contact the professor ahead of time. I applied to one of those schools and didn't know that I needed to contact the professor ahead of time, and I did not get in. You really need that professor. So make sure to check that out as a tip moving forward. But yeah, so after that first year, I still had classes, but it wasn't every day. It was more like your normal college courses where it's like every once or 3 times a week for an hour or so. And then I would go to the lab that I joined and work. And how much I worked is kind of dependent on how well things are going. Like I was always working. It's just if something fails early in the day, I was just done a little bit earlier. Now most of my stuff is data analysis because of my research. So I spend a ton of time just on the computer working on stuff. And I'll do that sometimes just like while watching movies because it's just like transposing data in Microsoft Excel. So I don't know if you count those as hours. I'd say I work on average probably 50 to 60 hours a week. And I would say I'm average for STEM PhD students. The expectation is sometimes higher, I would say. But this is in a pretty highly ranked program.
Is the 50 to 60 hours in addition to classes, or is that including classes and lab time?
It's including classes and lab.
Okay.
So after those first 2 years, classes were done, and the expectation is a little bit more time is spent in lab. You also know, I spent 3 years in grad school not knowing what the heck I was doing. I talked to my classmates. I'm not alone in that, I swear. But then you kind of figure it out. So a few of you were talking about not knowing what was going on, and you get kind of comfortable with that, and you kind of learn how to just like keep moving forward despite it. So that's, I think, the best part of grad school.
Rachel, I think this is great, and what you're describing as your grad school experience is similar to what I had. So, not to date myself, but I'm glad that things haven't changed that much since I went to grad school. But can you expand a little bit more on like what's different between classes in grad school versus an undergrad, or doing research in grad school versus an undergrad?
Yeah, that's a great question. And I think that's something I forget about now that I'm so far along, or it's been so long since I was an undergrad, I guess. But yeah, so the big differences I'd say between my undergrad days and grad school is all of a sudden I'm really busy. I don't have any time. I thought I was busy in undergrad, and I wasn't. I just kept myself busy by choice. But yeah, so I had to learn how to balance classes and research my first year. I didn't need to do that for very long, but those first 2 years are important for classes. So that balance and figuring out that in grad school, you have to get good grades to get in, but you don't need good grades once you're there. You just need to pass. Nobody cares if you get an A in your classes in grad school, in my experience. If you do, great, good for you. But if you get a B, that's better if you were able to spend enough time in lab to get something done. And it's all a balance. If you fail your courses, don't hold that against me. Just kidding. You should still study. It's still important to know what's going on. But yeah, so I think that was one of the big differences, is the expectation was more on figuring out how to work in the lab. So for actually working in the lab, it's quite a bit different than undergraduate in my experience. In the sense that you go in, and similar to undergraduate, you don't know where anything is or how to do anything. And even if you did, they probably do it differently in that lab. So it's important to be able to ask for help and to take good notes when people show you how to do things, because they'll show you and then you're on your own pretty much. Or that's how you should try to expect from yourself. Because it'll come off the best if you're able to have that self-motivation and drive. to get that stuff figured out. Yeah, so it's a lot more independent. And then troubleshooting. So like I said earlier, it's not stuff that usually works that you're working on. It's usually new or difficult things, or it's a new method you're making, or you're looking for a new protein. All the cool stuff is new, and all the new stuff is not figured out how to do it yet. It's not optimized. So there's a lot of optimization time, and I don't think I realized that when I was going into it. In undergrad, you're handed a lot of stuff that people already figure it's gonna work at least. They did that legwork for you usually. Not always. And if you have a professor that's not doing that legwork for you, good. And if you can do it yourself, even better. So I think that was a big change. Everything moves a lot slower than I thought because of that. Like, I'm still working on my first paper. It's just me and my professor, so it's a lot of work, you know, and I think when I saw scientific papers as an undergraduate, I thought they'd just happen. You know, and now I'm actually writing it, and it's been months and months of writing and reanalyzing data. And, you know, this paper is 3 years in the making for me, you know? So when you think about how long things take, it's just, that's a different thing for sure.
Do you, Rachel, do you feel like there was any big mistake that you made along the way in your first 3 year, you said 3 years, right? That you want to tell your friends about so that they don't go in making those same mistakes?
Yeah. So I think I've been thinking about this a little bit, and I feel like there are so many stumbling blocks I had along the way that are just like obvious in hindsight. So you guys might like think that they're not things you need to worry about, but they are. These are things that I'm not the only one. It's my peers as well. So keep a good lab notebook. That's important. It's a good skill to have. You should learn how to do that in undergrad. Things will get more strict. In grad school, there are people who don't keep a lab notebook sometimes. That is very bad. You can get a huge fine for that. And then when you go into industry, if you want to go into industry, lab notebooks are critical. You can keep an electronic lab notebook. That's fine. Learn how to do it though ahead of time. Nobody will care what you use as long as you are competent at using it. And then logging your data. So most of my stuff are about data, logging it early. But then as far as finding a lab, that was something that people really struggled with that I knew of, because it's very tough to know. So let me back up. In PhD sciences, you're paid from research funded grants or funded research grants that your professor has. So you are paid for most of these PhD programs, I believe. Were you, Adira? Yeah, okay. Yeah, so even
that's
engineering.
Common in the STEM, at least in the science field. It can get a little less common once you start going to the engineering field, and a lot less common when you're talking about masters.
Yeah. So I completely forgot where, oh yeah, so we get paid. So your professor needs to have money for you to pay you in order for you to join the research lab and do research in a PhD program. So finding out who had money was very difficult because professors aren't always, for some reason, aren't always like super open about it. They don't, I don't know, but you can actually look it up. There's a place online called, I believe it's the Grantome. Let me just double check on that. And it's an NIH site where you can actually see what funding people have. Yeah, grantome.com. I believe that's right.
Can you spell that?
Grantome. Yeah, and it has the type of grant, so like NIH, NSF. So this is a very available website, and I didn't find out about it till a year ago, and I could have saved myself having so many conversations with people about whether they're funded and what they're funded for. So as I've been looking at postdoc opportunities, I've been using this quite a bit to see what people might be working on when I want to work there. As far as other things, the GRE I thought was pretty straightforward. I only took the general GRE. You can look online. Most schools only require the gen. Need a refresher. I think that's most of the application process. letters of recommendation actually are important. I will say that. Your letters should come from people who actually can talk about you as a person, and especially if you can, as a scientist. So if they had you in a class and you talk to them about your life or what you like to do, that's great. You want to make sure they're glowingly positive. There's no such thing as an over-the-top letter of recommendation, which always seems really germy when you write it, but it really is for the best. It'll come through better. Don't ask for letters of recommendation from people where you just sat in the class and never talked to them an entire semester. That will come off really badly. Do make sure it's somebody you know. If they allow you to do 5, but you only have 3 strong letters, only send 3 if that's all you need.
Along those lines, who did you ask for help in terms of navigating the application process, but also thinking through, what subjects you might be interested in, what kind of research you might be interested in? Did you have like a mentor or someone who guided you while you were an undergrad?
Yeah, I had a couple of people I worked for research, and I was pretty close with them. I would just ask them any questions I had when they were available. And they were absolutely wonderful mentors in that way. And they wrote me glowing letters of recommendation, which I know because people actually told me that once I got to grad school, which is why I stress that they are important. I think that was also a factor in my getting in. That was one of those things that was a nice touch on top. Jonathan, I'm reading your question now. Yeah, so networking is a big part of graduate school. And I would say that in undergraduate, it wasn't to me, or I wasn't worried about it. I don't know. But networking in grad school is a challenge. Scientists tend to be a group of introverts. So even if you are comfortable going and reaching out to somebody, sometimes the other person is less. So you have to kind of learn how to have your 2-minute conversation with someone. So how do you introduce yourself quickly and form a relationship quickly? In undergrad, I didn't really have to do that. It was a smaller campus. I knew a lot of people. They knew each other. It's the Midwest. Yeah. So now job conventions, letter outreach, LinkedIn. So I haven't been on the real job search yet. I'm looking somewhat at a postdoc, but even that is not really on regular job sites. Most of my networking is in person at conferences. Yeah, I guess that's most of it. And then also reaching out to professors when you first start at a master's or PhD university. So it's a little bit faster paced. People really want to know who you are, what you need, and what you want from them. So it's really good to get good at that kind of quick, like, hey, I'm this person, you don't know me, that's okay. Here's like what I have to offer or what I'm curious about, and keep going. I also now have to be good at telling people what I do, or it helps a lot because people will ask, and I at least personally, morally believe that it's our job as scientists. I'm paid by taxpayer money. I should be able to tell anybody on the street who asks me what I'm working on, what I do. So I've practiced talking about my research a lot. And that's something I didn't really practice in undergrad, but I would encourage, if you go for an interview, practicing that a lot. It's what people want to hear about.
I have a question. Would you say that reaching out to like the professors of your specified major before you go to the master's school that you're interested, would that be a good idea? Like reaching out to the professors of that? Yeah.
Yes, I definitely think that's a good idea. And it can be intimidating to send those emails. I'm guessing my email will be available. Feel free, if you have any questions about that, to let me know. It can be intimidating, but I think it's a really good way to let people know that you exist in a friendly way and in a way that will let you know if that's somebody you really want to work for as well. A lot of times professors won't get back to you. Emails get buried very quickly. Something I heard recently is if it's like somebody you want to work for, you can wait 3 weeks and then email again, and then wait another week and email again. After that, don't. Like there's that 3 is enough.
Okay.
but that can be a good amount of waiting. And then Maddie, I saw you asked about working with your advisor a lot. advisors differ greatly from person to person. How they interact with you is wholly dependent on the advisor you get. I was really thankful to have 3 rotations. I didn't enjoy one of my rotations very much. I really liked the science, and I still work with that lab quite a bit. We collaborate. But the professor and I it just didn't work. Like, we weren't on the same wavelength. And he's my mentor, or my co-mentor now, and like my biggest cheerleader, but in his lab, it wasn't a good fit. And I was able to tell that. My current mentor, it worked really well for me. I prefer a structured approach. I like to know what I'm gonna get. Uncertainty is something I don't like. So I knew that going in. So my advisor, current, had a welcome guide that outlined exactly what she expected from me for basically the entire time I was in her lab and out. So I really liked that. And we have a pretty good relationship. Everybody butts heads with their advisor. You are together a lot. I've seen it described in literature by people's advisors as a marriage. And there's a whole bunch of papers out there about choosing the right advisor. If you search that on Google Scholar, you'll get plenty of places to start. Yeah, I think it's really important. Your mental health in grad school is going to be challenged by actually doing research and coursework. So make sure your lab is a good supportive home was my goal, at least. And I think coming from the Midwest, we all need a little extra of that compared to many, just because of what we're used to. The Midwest is very supportive. And if you guys end up going to East Coast, West Coast, it gets a little bit more intense.
So, you touched on something, Rachel, about, the 3 rotations. Can you walk everybody through what, your first, and you also mentioned classwork and choosing a lab and picking a lab. I'm guessing, at some point you had to do like a prelim type of thing when you picked your lab. Can you walk everybody through what some of those milestones are to check off?
Yeah, of course. So when I got started, we had your basic orientation to get going, and then started in our first rotations. We got 3 rotations to kind of figure out where we wanted to go for a lab, and then an optional 4th during the summer. So that's your whole first year. You have some coursework first and second semester where I was at, and then the rotations themselves. So you do research in these labs, and you try to get a feel for whether or not you like the science, the people, is it a good fit for you? And the lab gets to decide, are you a good fit for them? Generally, this works out, especially you'll find universities that only have about 4 people per class, or maybe 5 to 10 per cohort of graduate students. And that's because they actually generally support you all the way through. Chem graduate schools are slightly different than this, but I don't think a lot. Anyway, for those of you in micro or sciences, that should be fine. So you go through these 3 rotations, and you evaluate whether or not you'd like to join that lab. And they evaluate whether or not they'd like you to join that lab. So this is a lot of that networking stuff and figuring out how to have those conversations that I was talking about. So these can be kind of stressful conversations. So it's definitely, something to prepare yourself for in that situation. But yeah, so you do your 3 rotations, usually something works out. And then at the end of your first year, you have your preliminary exam, is how my school calls everything and lays it out. So for my program, we had to write a review about a topic that was given to us by the faculty committee. So we got a few papers to start with, and then wrote a 10-page review, double-spaced, in a couple weeks, and then defended it in person. So these in-person defenses of things are pretty unique to graduate school generally. And they're not as bad as anybody thinks they are, but it is intimidating in the moment. So it's just general questions about the topics that I wrote about. So for mine, it was I think it was HIV and microbial and gut microbiota. So I got asked questions about the immune system, about microbiology, about biology. And then, so once that's done, you move on to your second year, you join a lab. And then at the end of the second year in my program, you do a comprehensive exam in which you write a grant. And grants are how you get funded in science. So you write a small grant for the project that you want to do for your PhD. So hopefully your first year you got a little bit of stuff so you could write up your project as a proposal for the whole project for the rest of your time there. And then you defend that in person. And then after that, you can either, so you pass with conditions, or you can opt out for a master's degree at that point. So some students choose to do that if they decide they don't want to do the research component, and then they end up not having to pay for a master's. But if you pass, you move on and you just continue doing your research. If you pass with conditions, which is very common, you just redo part of it, and then you move on to doing the rest of your graduate work. At the end, you defend your thesis. That's in my program on average 5.5 years. It does seem long, but you are paid the whole time and we get pretty good benefits. So I don't think a lot of students are motivated to get out of the Rocky Mountains. So you might find schools with shorter graduation times, but I think 5.5 is pretty average for the programs I've seen, yeah. But yeah, so then you defend your thesis, which in my program is more of a formality than in others, I think, because our comprehensive exam kind of almost serves as part of the defense questioning. But yeah, that's the entirety of it. Yeah, and I didn't know most of that going in, but you can look up student handbooks of places you're interested in and find most of that information.
All right, we're almost out of time and we're going to get booted out of this room into the main room in just a minute, but I think we have time for one more question. And Jonathan's asked, what academic or social skill did you learn that would make you competitive in grad school?
Yes, I think time management, for me at least, was the big one. Teamwork is incredibly important as well, though. You are usually working on teams. Productivity, is more person dependent, but yeah, definitely time management is important.